Okay, so we have another one of these Alpine Mrv-1507 amplifiers on the bench here, and this is in for repair. I love working on these amplifiers because of the split amplifier power supply design in these. These are one of the most easiest amplifiers to troubleshoot from Alpine because of that configuration. A lot of the single board designs are actually harder to troubleshoot because you can't turn the amplifier on without the power supply in one section, in one board. It's kind of confuses things a bit. But with this, you can actually separate it and actually get the power supply working first, then move on to the amplifier. I really like this design. They are pretty good, pretty easy to troubleshoot, and there are usually no surprises. I usually see the same thing over and over with these amplifiers. It's usually people run them at 2 ohms bridged when they should never be ran 2 ohms bridged. There are a few videos floating around on YouTube where people run these at 2 ohms bridged and they show how much massive amounts of power they put out. Yes, they will put out that power, but not for very long. I guarantee you, you will let the smoke out eventually. Run these 4 ohms bridged and they will run comfortable for a long time. Also, another thing is people put counterfeit parts in these. Stop buying your Fets off eBay. Go to reputable dealers like DigiKey, Mauser, Newark, because their manufacturing standards on the cheap Chinese crap is nowhere near where you're going to get for a regular component, and you're not saving a lot of money doing so by going through eBay. Trust me on that one. Go to eBay for your obscure parts that you can't find through any reputable dealer. That is your last resort. Yeah, like I said, don't run these at 2 ohms bridged. And these things have cycled around between hands. I'm telling you, these things float around on eBay for a while. People scoop them up and they buy them thinking they're working, and they're not. They have issues. They have notorious issues for the indication lights, the power and protection. Once these things see problems, that these indicators get all screwed up, the IC that drives them, the design on that could have been improved. I always see a lot of problems every time one of these is blown up. Something always happens with the LED indicators about 90% of the time. A lot of the time it's user error. Another reason why this blows up is because somebody takes the screwdriver while this is on and touches the screwdriver to the case, to like a speaker terminal, and boom, you just popped your amplifier. Shut these things down, disconnect the fuse. Even once you have the power isolated, even take a wire and short the positive to the ground on the amplifier, because there's still stored energy in the amplifier. That will ensure that this amplifier will not give up the ghost when you're trying to rewire it or hook it up. I see it a lot that somebody will, try to tweak something or try to change their speaker configuration while the thing's on, and that's it. That's all it takes. One little spark to the case with the screwdriver, and boom. I think this one came in on a similar situation like that, where the person was doing something with the wiring and sparked the case to one of the grounds or the power to the ground or something. I don't know. He told me that the amplifier has a power supply issue. He said he saw smoke come out of it. He thinks the amplifier section's okay. So other than that, that's about as much as I know, is what I just said. So let's flip this over and see. I haven't taken anything apart yet. There's no case screws on the bottom, so I don't know what to expect yet. So I'm going to go to my other camera and flip this upside down. Okay, there's a napkin in here. Not sure I like seeing that. That usually means there's parts floating around. So let's see what's in this. Okay, this probably might be screws and stuff. Okay, yeah. So there are screws and there are 2 transistors. They look like they're from the preamp section. So this has been into before, and the amplifier section has been touched. So I'm assuming that the amp board has problems as well as the power supply. We don't know yet. So that's our first clue. Let's see where those parts were removed. Okay, they were removed from one of the channel pre-drives. Like here, there are 2 pairs on this channel. Let's see if I can get this closer up. There are 2 on this here and 2 here. There's supposed to be 2 and 2 here, and there's 2 spots that have no parts fitted in them. So somebody was chasing an issue in the amplifier section, and that's as far as I know right now. The power supply looked like it had exploded at one point, from what I can tell from some of the carbon dust on some of the components, but the Fets actually look like they've been replaced. They don't look original. The folds on the legs don't look original. They're not perfectly straight, as I would expect to see in the original. So the power supply has been worked on, as well as the amp board has been worked on. So that is about as much as I know. I guess we'll have to check the Fets, make sure there's no shorts. That's usually one of the first steps I make before going too far. Let's see here. Yeah. I don't see any other missing components. Yeah, I think the only thing you have to take this whole thing apart at this point. There's no ifs, ands, or buts. You have to. When you see previous work done here and work done here and parts floating. Like I said, this has a split design. The power supply is split here, a switching supply, and your amplifier is on this side. And if you actually take this connector out, just get something in there, and it's got a little clip on it. You remove that. You take these 2 screws out. Remove these 2 screws. And take this cable that goes all the way across over the amp board. It plugs in right here. Remove that. Now you have isolated your power supply from your amp. So now you can actually technically power this on if all the Fets are good, and test your voltages at this connector strip. Usually the outsides are the positive and negative. The power pins, the 50-volt power pins are the 2 outer pins of this connector, and the ground pin is the second one in on this side and the second one in on this side. That's how you can test your positive and negative rails on this pretty quickly. And once you verify that you've repaired your board, then you can go ahead and proceed to plug everything back in and work on this at a current limited supply, limited to about 4 amps. Because if there's something wrong on this side, you could possibly damage your power supply board again if you've already repaired it. So I think what we'll do is fire up the microscope and see what else we find. The fan's free. That's a good sign. Yeah, alright, so I guess it's the time to start checking the Fets. Let's get the microscope over here. I want to show you very quickly how to go through these Fets. It's not super complex, and I'll try to get this on film here. Put your ohm meter on ohms. And get a better angle here. Okay, all right, so you're watching here and here. So basically the FET is gate drain source, or gate source drain. I can't remember the configuration right off the top of my head right now, but I'm not too worried about that. Get this pointer out of the way. All I want to know is if the gate is shorted to any of the other pins. And we got 15 meg there on from gate to source or drain. Gate drain source. I think it's gate drain source. Something. It's been a while. So there's no short there from gate to drain and source. And we're good. You're going to get numbers like 100 ohms or a couple K or a couple meg ohms because you can switch the MOSFET on just by your meter leads. And you can really skew the measurement. The only way you're ever really going to check these properly is if you remove them. But I usually don't remove them unless I see a short. And I do not see a short. So once I go through the whole amplifier, once the whole power supply section, if I don't see a short, I will usually current limit my supply and attempt to turn it on, because there's no reason to remove the part unless you know the component is indeed shorted, and you're never going to get a reading that makes sense in circuit. So I'll go through the whole amp board. I'm not going to bore you with that. And let's see. Let's go to the other camera here. Yeah, I'm going to go through this whole board and test the FETs in the power supply just the same way I showed you on that one FET. And if they all show the same characteristics, I will power the amp board up and we'll see what it does, see if it produces any rail voltages for the amplifier section. That's what I was saying. This is a very nice design. I like that split design because you can isolate that right out. And that's it. So I will go through this and we'll be right back with you. Alright, so I have the the power supply hooked up to my voltage power supply, and I have it limited to about 4 amps. I haven't turned it on yet or anything. I just want to get everything on film here so we can experience this together to see what's going on. If the fan spins, then the chances are we're in really good shape and the power supply is turning on, and if the current doesn't run away on the power supply. Alright, so I have the remote lead turned on. I'm going to change cameras here and we'll see what it does. Alright, so I have my power here. Let's give it a whirl. I've checked all the power supply FETs and they all read the same thing like in the demonstration, so I feel confident that if we plug this in we're not going to let any smoke out, and we are current limited anyway. So let's see what's up. Alright, fan turned on and we're drawing 340 milliamps with no amp board connected. So that looks promising. That looks promising. So now I'm going to get my meter and go back up here to my voltage meter, put that in volts, and I'm going to test those pins I told you about. I'm putting my probe on the second pin from the bottom and the bottom pin, and we should get about 50 volts if this is working. Wow, can't ask for better than that. That's beautiful. And now I'm going to move my positive pin up to the very top pin, and we should get minus 50 volts. Well, holy shit. It works. Yeah, the power supply is working fine. So that probably means that the issues are not in the power supply, they are in the amp board. But I usually like to pull I'll be pulling the power supply board out anyway, because there are plenty of known problems that are with this amp board. There are traces that snap in the power rail section, and the LED drivers usually suffer some damage. And like I said, there's been some previous damage to these FETs before, so this is no guarantee that this power supply is 100% functional, but I feel confident enough that we can move on to the amplifier section to start troubleshooting why these components are removed. My guess is we're going to be dealing with some FET issues or some noble resistor issues, something like that. We don't know. We could even have plus and minus 15 volt issues on these two transistors down here like usual, or some of the diodes, the voltage Zener diodes could be whacked out. A lot of odd things can happen when you hook these up incorrectly. So let me do a little probing around here, and I will be back with you. Okay, so I'm going to be checking the two parts, the two components that were pulled out. These are part of the pre-driver section for the Fets. And anytime you see parts removed like this, you can't guarantee the parts that are in the positions of the other side are the correct ones. Some people will swap these around and mix things up, so they will create more headaches and rabbit holes for you. So just make sure that the proper component is in the proper component location. That is the one thing I would definitely suggest before powering anything on, is make sure nobody's been in there fiddling. We're gonna have to remove these boards to make sure there's no solder shorts or anything like that. We're going to be putting these two back in if it does indeed go in those two positions and not, other way around. And I will chase down why these were removed. If somebody removed these, then that probably will designate that this quarter of the amplifier is having an issue with either the MOSFETs or something in the circuit. So that's about where I'm at right now, is going to verify the components with the board and then move on to MOSFETs, see if there's any shorted MOSFETs. But before I do that, I want to make sure that these two components that are pulled out are indeed good, so we're not putting bad parts back in the board. So I got my component analyzer here. It's a DCA 55 made by Peak. And let's see what it says here. Component analyze. PNP silicon transistor. If it was shorted, it would, or open collector or something, or open emitter, it would have said something. So that part is good. Let's check the other part. Let's do a test. Analyzing. PNP silicon transistor. So these two components are good. Why they were removed, I don't know. Something was probably overheating and they thought these were the culprit, because these will probably get super hot if something is wrong in the circuit. They do get warm anyway, and that's the tricky thing, is these components get piping hot on these each side of these channels. And just because they're getting hot does not mean they're failing, because these are meant to be warm and they operate very warm. So yeah, that's it. We're gonna be pulling the amp board. I'm gonna be stripping the boards out at this point, because there's nothing we can do from the top side at this moment. All right, so I have the power supply board flipped upside down because I'm just looking at some of the known points of failure, and over usually by the power inputs is usually where the damage occurs to some of the traces. So we're going to check that position on the board. Let's go to here, and as you can see, the terminals are right over here for the power supply input, and usually down in this left corner you'll usually get some damage on almost every single one of these I see. So let's look down a little further to see what's going on. It looks like some heat buildup in this area. What I'll usually do is scrape this down and bridge some solder on this copper from connection to connection. It's pretty heat soaked here. Yeah, it's disconnected right there. So my guess is we might see some LED indication issues from some of the damage caused. Usually when I see this, I'll see indication issues most of the time, but not always. We should get some alcohol and clean this up a little bit, see if I see anything. Yep, just get it all nice and clean as best as you can. I mean, you can repair this by a couple different means. You can use some wire, you can try and bridge solder. You can use some used up solder wick. Yeah, it's starting to lift in a few different places, so I think a wire would be a better means of repair here. So let me just get some of that gunk off of there. Yep, I'll be using a wire for this, just an exposed wire. You can use some solid wire that you find, you know, some electrical wire. I already have this. Let's see, what am I using? It's a 20 gauge solid wire. It's pretty good stuff to just bridge this gap. So let's get this thing soaked up with some flux. And all this is doing is this connects all the way through, all the way down here as well. So it doesn't matter if you flow all these connections together. Now I'll take my needle nose to hold this. It's good for now. Now I'm just going to heat a section at a time. So it doesn't pop out on me. I'm going to bend this down a little bit. And try and get that connected down to that other pad. Like that. That's all you need. It won't break there again. Just cut the excess off. And that's it. That will carry the current. Now we'll just take some more alcohol and clean up that area. And that should do. So now I can move on to the amp board, because I'm not concerned about the power supply right now. It does seem to function. We won't know if the indication of the lights until the 15 volt feedback from the amp board comes back and feeds this board and does all its tricks. So I'm going to be pulling the amp board out next. Alright, so I've actually just temporarily put the power supply board back down to the amplifier, and I've started removing screws from the amp section because that's what we're going to be working on next. I just want to go through the Fets on that side to see if we have any problems there. So let's go to the other camera here and see if we do have any issues. So I'm just going to be testing the same way we tested the power supply Fets, gate drain source. And go up to the meter here. Go to ohms. Okay, 25, 18, 25, 18. If you're getting a repeat reading across all the Fets from gate to drain and gate to source and source to drain, yeah, these are looking okay so far. I'm looking for dead shorts. In the amp section, it's a little bit trickier because there are resistors that are in series. I think it's in series. I haven't looked at the print in a while on this, but there are resistors that tend to burn out. I think they're in line with the gate. But all the numbers are, from my recollection, are looking normal. I don't know about that 800 ohms there. That seems a little low. 800. This is on that side where those parts were removed. So I'm seeing a FET that was replaced in this channel in that quadrant that we had the parts missing. So yeah, there are issues in this side of the amp. 280 ohms. Yep. Okay. So we're definitely seeing some problems here. I'm going to have to pull these Fets and check them one by one. Yeah, not good. There's some suspicious readings for sure. Yep. And they're all hooked up in an array, so if one looks bad, they all can look bad. That's the trouble with this. So the only way to really do this is to pull them all out on that side. This side actually might be okay. All these Fets might be okay, so I might end up pulling all these out and seeing if the side of the channel still swinging. But as for this side, we're definitely dealing with some issues on this channel. So well, that's good though. At least we're finding some problems, and this basically told us where to look. Is pulled out components. I just did talk to the person that was that I'm repairing this amp for, and I asked them about these components that were pulled, and I guess there was somebody previously trying to repair this for him and told him that some of the components were no longer available for this amplifier, which is kind of bullshit because you can always find a substitute or a newer version of the components that were in there. I know the originals, I think they were discontinued either due to normal obsolescence or the lead content in them. But they have renamed the components to a BPF. I think they're BPFs, and they're just basically a lead-free version. So components are available, and if you, like I said, throw an eBay FET into this channel, you might as well throw gas onto a fire, because there's no way that those eBay FETs are going to act normal along with these older original FETs. Those eBay FETs are ridiculously way out of spec to run in a final section of an amplifier of this class. So yeah, like I said, don't buy crap parts. All right, so I guess we're just going to be removing all those FETs and start there. Okay, so I'm getting ready here to test for the first time the amplifier section. I have taken out all the FETs on the suspected bad side of the amplifier for that channel. This is all one channel on this side. That one FET caused all those P FETs to basically fail, and I took the other FETs out. This channel here seems like it may be okay. We're going to find that out right now. So we're first going to turn the amp on with the amp plugged into the power supply to make sure that there are no runaway or anything like that. With all those FETs removed, we should be okay if this channel is good. So let's see what we get. Oh, power supply turned on. Didn't kill the thing in current limiting. It shot up to about 3 amps and then back down to 1.5 at idle. So yeah, let's turn the signal on here and let's see what we get. I'm pretty confident I think we're going to get something out of this. Oh, yeah, there it is. One channel lives. Of course, we're going to have to go and check the bias and all that, the idle current, and make sure all that's all good, but that's a nice, clean signal right there. All right, so 1/2 of the channel is working. The amplifier section is working, so very, very good. So now I'm just going to put I'm going to put one N part and one P part in this section of the amplifier, and that should get this thing to output a signal. At that point, we'll be able to see if there's any more damage further into the pre-drive, preamp section. If this thing outputs with 2 parts in it, just two, one P part, one N part, then we can assume that we put the other array of parts in. We should be good, because all these parts are basically connected together through the schematic. You can tell that they're all pretty much, all the drains are connected. A lot of the parts are connected together. The gates are all the same drive for the N side and the P side. That's where it splits off, but other than that, everything else is the same. So I'd feel confident putting one part in each side and test it. This is great. We haven't even dug out the service manual on this yet because we haven't had to. I think it's been pretty self-explanatory, the problems with this as things have been just unfolding. So I'm not too concerned yet. This is going well. All right, so I think I'm gonna just, like I said, just gonna throw one P part, one N part in and fire it up again. So I got one P part, one N part in the amplifier section that we had taken all the FETs out of, and we still have everything good here. So let's fire this up and let's see how just those 2 components work. See if we get an output, then we can pretty much prove that everything here is probably okay. Let's turn the signal on. Okay, we have our one channel working that we know, and now let's check this channel. Hey, all right. So we're good there. Looks like both channels are working. So now it looks like it's time to put the rest of the Fets in and set the idle adjustment on it. And if it looks good from there, I guess we beat the thing up a little bit. Okay, so I've put all the new Fets in the, the rest of the new Fets in that channel. I've got the scope hooked up on both channels now, and we're going to see if we get both channels live. Let's power it up. Nice. There we go. And she's idling around 2 amps or so. So we're good. We are good. So now, I guess at this point, with both the channels working, I should verify that the LEDs are working properly. I have the ground looped back to the second ground. That's the only way that the amplifier knows that it has a complete loop for the head unit. And yep, she's flashing red. So that usually means second ground not detected. So it looks like we got to go back into the power supply again for more diagnosing. I think it's that IC that usually goes along with the power supply problems. So yeah, well, I'm happy with the outcome so far. At least we're getting signal. That's the most important thing. The rest is just kind of cosmetic stuff. So I'll have to verify the 10-volt low and the like I said, the music signal, and see if we can do about that. Yep, I'm gonna have to look through the manual again just to verify that I am correct, to make sure before I dig any deeper. But yep, I think we're good here. Before we go on to any real testing, I want to get that taken care of and have these heat sinks re-greased underneath where the boards connect to the heat sink, and fasten everything down and give it a good run up. Okay, so I went through and checked the manual a bit, and I had the ground connected to the wrong spot for the loop feedback. It's got to go back to the power supply ground to verify that your RCAs aren't floating, and we're good. It's all green lights, and the music light is flashing, indicating that we have a signal. Shut it off. Solid. All right, so that's working. I'll verify the 10-volt low. No, everything looks good. So the only thing we have to check now is the biasing, and that's pretty simple. There's 2 studs, and you can check my other videos on these 1507s. I went into detail, so I'm not going to get too in-depth on that. So I just want to make sure our bias is good. I'll put this at millivolts, and we're looking for around 1 millivolts on the 2 studs. Make sure you don't slip. All right, we're a little high here. And you gotta do it once. Yeah, we're a little high here too. So we gotta back those down. So I'm gonna back them down now. That's way hotter than I like to see. Be very careful that you don't slip on your probes here. Where my tweaker? Tweaker, where are you? All right. No, that's not big enough. There we go. All right, so let's back those down. Make sure we're not in current limiting, because that will affect your biasing. And on this particular one, counterclockwise is turning the bias down. And it's real touchy. Get as close as you can. I'll leave it there, walk away. And walk away. All right, so you're gonna let that warm up for a little bit and recheck the bias again, so because you want to make sure it's a little warmed up before you really finalize that. But you want to get them close as soon as you power the amp up, because if they're way off, you can definitely damage the MOSFETs again. So it doesn't matter if they're all the way down. It's just anything over 1, you can anything greater than 1, it just increases your chances of blowing these MOSFETs up. I mean between 4 and 1 and 4, you're gonna be okay for a little while. But once that thing starts flying off, 10, something like that, yeah, you better be careful, because you can latch up your MOSFETs and have a really bad day. So yeah, I think at this point, what else we got left to do here? Grease it up and give it a beat down. I think that's about it. So, all right, I guess I'll do that, and we'll be back. I want to mention one little tip on these amplifiers. When you're working on them, take the EQ adjustment board out of the amplifier and tape it up and plug them in on top. Never run the amplifier section without those pots hooked up. You will open loop tons of op-amp circuits and cause these amplifiers to run wild and blow shit up. Yeah, so never run these amplifiers with the EQ adjustment potentiometers disconnected. That's just that's a tip of the day right there. Something small like that will ruin your day and start blowing stuff up in sections that had no problems. Been there, done that. So yeah, back in the earlier days, when you're just learning out on this stuff, stupid stuff like that, I think we're good. Yeah, like I said, I think we're just gonna run this up on the power supply. Now I can move it out of a current limited situation, and I might as well go to the other camera here. Yeah, now we can kind of get this out of current limiting. Once I run a few more checks and make sure nothing's going to happen. I don't think it's going to, but I'll move it off my current limited supply, which is only good for about 10 amps, and I'll move it on to my PR60 trip light, which is capable of delivering 60 amps. So I think with 60 amps and two 12-inch kicker 400-watt subwoofers, running 50, 60 hertz for a while gets these things warm. So if it takes that, it's gonna take whatever you're gonna throw at it. Except, you just gotta treat these things good, and they'll live a long time. Yeah, I guess I should stop bullshitting and just get the rest of this done. So I will, like I said, grease up the heatsink and we'll start doing some testing. All right, so I have it off the current limiting power supply, and I have it up to my trip light, and we're a little warm at idle. That's good. It's been sitting here for about 20 minutes just idling. So now we're going to hit it with some good current and let it become unleashed from its cage. All right, so let's go to the other camera here, and I'm just gonna do this slowly because I don't know what's gonna happen. I'm hoping everything's good. I'm gonna get the pots down to minimum, and let's see how it works. Sounds good. Let's turn the gain up a bit. That is insanely loud in this. That is insanely loud in this little room with those two 12s. It's like being in a clown car with two 12s. Holy shit, that thing's loud. That's insane. Wow, that works good. So yeah, I'm just gonna put it on a slight sweep at a lower frequency and just let this run for a while so it doesn't annoy all the neighbors and everybody else that's in this house. So I'm just going to put a low sweep frequency and just let this thing idle and run about 15-20 amps for a while and see how it works out. But other than that, I think this is fixed. So all the LEDs work good. Everything's checking out fine. I get power out of both channels, 2 speakers, sounding good. So I hope you like this video. Like I said, you know, I've done so many of these 1507s now. There's tons of videos on my channel about this, so I didn't get into like all the soldering and stuff because I hate doing repetitive things, even though I keep getting these amplifiers. But there's not too many people fixing them, so they end up here. So I figured I'd stop doing the in-depth repairs on them and just kind of give you the kind of, I don't know, maybe a rush through it, just to kind of get something out there to show you guys. But every once in a while, I mean, even with this video, there may be some new tips in this video that weren't in others, so who knows. But I don't know. Alright, so I hope you enjoyed this video. We'll see you in the next one. Come on back, and when I have a next video come up, hopefully it'll be soon. So, alright, have a good night.